How do you solve this equation? Now, the reflex people often have is put all the x's in one side and all the numbers in the other, but you got an x squared and an x, and that's not going to work. What kind of equation is this?
Quadratic?
Quadratic. How are we going to put it in the form of a quadratic equation so we can solve it?
Get all of it on one side.
Yeah, so, I'm going to subtract.
That would make me do it.
And I really want to see you, when you solve equations, to write out stuff like this. Don't just move stuff from one side to the other. Don't just cross things out because you want to cancel them. Okay?
See you all later.
I don't acknowledge cancellation. It's wrong if you cancel it. Okay? Okay. Yeah, I saw somebody do this. X minus 3 times x plus 4 times x minus 3. Cross those out and you end up with x plus 4. Okay? It's easy to do if you don't understand the rules for cancellation. And I think that the collective understanding of the rules for cancellation in any typical pre-calculus course, at least at the beginning, has a better than 50% chance of being 0. Okay? Have anybody known all the rules and always been able to cancel correctly? Even if you put all the heads together, I'm not sure it could be done. Terrible deficiency in algebra courses. Okay? That's why I don't acknowledge cancellation. Do it by the rules. Okay, so, I've said that before. Anyhow, that's going to give you 0 over here. It's going to give you 4x squared minus x minus 2. Uh-oh. Bonehead carelessness here. Plus 9x minus 2. You got to distribute that negative, right? And that's minus 10, not minus 2. No, it's minus 2. No, it's minus 10. Don't do like I do. Don't skip steps. Okay? So you get that. And now, easy to solve, right? So that's really easy. You just got to see that, if you've got x squareds and x's, no matter which side of the equation they're on, you're going to have to put it in the standard form, equal to 0, and use a quadratic formula. Now maybe you'll get one little factor, but it's unlikely. Okay? So you don't expect that. And if it factors and you want to solve it by factoring, that's fine. Okay? Later on we'll kind of nail down that process. Okay. Now you got a polynomial. With zeros at x equals 5, x equals negative 4, x equals negative 6. And y-intercept is I typed AY for at, okay? That's why it's next to T, I got clumsy. Y-intercept is at is 0, and it has A times C. And that would be 5 times negative 6, which is 0, negative 30. And this is number 9, incidentally. And this one was number 7. Okay? So we're getting a picture already? You visualize this? Well, maybe, maybe not. Some people are better at visualizing. And it doesn't hurt if you have to draw a picture. Matter of fact, it's safe to draw a picture even if you think you can visualize it. So we got a 0 at 5, and we got zeros at negative 4 and negative 6. So X's there to indicate those are going to be zeros. We've got to go through those points, or touch those points. It's, y-intercept is at 0, -30. There's -30, we've got to go through that point. Okay? Far to the left, it's positive. To the right of the rightmost, it says to the left of the leftmost 0, it's positive, right? What's the leftmost 0? That's this one. To the left of here, it's positive. To the right of here, it's negative. Sketch at least 2 polynomial graphs matching this description. Okay? Well, it's a polynomial. This is the leftmost 0, so it's got to go up here, and it's got to go down over here. So it's got to come down to this 0 from somewhere up high. Okay? It's got to, let's see. Comes down here, can it go through this 0 and come back through this one? Well, if it comes down here and comes up through here, it can't get back down here. Because it can only go through the x-axis at a 0. It's got no place to go through the x-axis until it gets over here. So it could satisfy the description except for having the y-intercept down here. If the y-intercept was up here, you'd come down, go up, come down, and keep going down. Okay? Can't do that here, so what do you have to do? Well, actually, the polynomial graphs are starting to look pretty good, except at the ends. Get a little better at the ends. I've drawn a lot of arrows at the ends of graphs that I've seen. Okay? Get better at the ends, and you'd be good with polynomial graphs. At least most of you that I've seen. So we can do this. We could come down here. We could start coming back up here and realize, uh-oh, I can't go through the axis, but I don't have to go through to have a 0 there. I can touch it just as if this is a little bit of a polynomial. I mean, a little part of a parabola. I come down here, and then I've got to come back up here, and I can't go through now that I'm down here. You know, I keep going down a little ways, just avoid that 30. Come over here and then down. That's one plausible polynomial. Okay? That's what it could look like. Now you don't have any more information in this. Okay? And if that's all the information you have, there are other ways that this polynomial could be drawn. Okay? I could come down from here and do the parabola thing here and come back up, and then come down and come through here and come back up here and come down here, right? Okay? So those are really kind of my only 2 options in this case. So draw at least 2. There are, you know, other possible options. Think and wiggle around above and below the axis. And we'll talk about that after we're sure we've got this process down. Okay? But that's 2 possible graphs, 2 plausible graphs for this function. Okay? Okay. That's all that problem asks. Locate the zeros, draw 2 plausible graphs. And many of you have drawn plausible graphs that were wrong, and I drew them. I mean, they didn't correspond to the function, but they weren't wrong because you wouldn't have known. Okay? Then I drew another one that corresponded to the function. So you see that on some of your papers. Now,
And you can do it with, like,
okay. Okay, now we've talked about this. It's been a little while, so we want to get this down. Should be in your notes, but I haven't seen a lot of notes being taken. You know, I get on you for copying down what I do when I ask you to do something. Now nobody's copying anything down, that's okay, because you always get it. But, you know, try to take notes on just words, just a few phrases that indicate what's going on, okay? Try to get in the habit of doing that. Okay, so, so we can start drawing the graph. So we have coincidentally the same points at which we had zeros on the exercise I just did, right? Not really a coincidence, I kind of set it up that way. Okay. Now, large positive x, all these are positive, it's going to be positive. And I'm not going to dwell on that, we talked about that quite a bit. Large negative x, all these are negative. How many of them are there? Well, there are 2 of them here. That makes 3, and 3 more makes 6, right? So you're going to have essentially a 6th power of a large negative number. Okay? Or at least you're going to be multiplying 6 large negative numbers, right? That's going to give you a positive. So it's going to be up here, it's going to be up there. The y-intercept is negative, okay? If x equals 0, you're going to have 36 there, you're going to have 64 there, and you're going to multiply that by -5, so it's going to be way down. Okay? So it could come down like this, but then it'd have to turn around at one of these, then it'd come back down and up here and through. That's a plausible graph, right? Okay? It's a little different than the one I had there because that one went down over here, but you get the idea. You can draw a plausible graph. If you can do that one, you can do this one. Okay? The thing we need to see is x plus 6 is squared. Okay? If you just did a graph of x plus 6 squared, what would the shape be? Well, that's just y equals x squared shifted 6 units to the left. Okay? It's going to be a parabola right here. Okay? Well, the rest of all this just stretches the parabola that you get from this, at least in the near vicinity of -6. So it's got to do, it's got to be parabolic. X plus 6 squared is a parabola. So x plus 6 squared times whatever you get for these numbers near 6 is just going to be a big old vertically stretched parabola. It's going to be really steep because those numbers are going to be pretty big. Okay? Now, at -4, your 0 comes from the x plus 4 cubed, right? Well, that's a horizontal shift of x cubed. So it's going to act like an x cubed function here. How's an x cubed function act? Comes up, it flattens out, and then it goes back up, right? Okay, and you're familiar with that. And then x minus 5 is just a linear function. It'll go through here like a straight line. So let's see if that works. It comes down here, acts like a parabola, turns around, comes down here, now it acts like a cube, and then it comes down through here and back up through here. That's what the graph looks like. Okay? And there's common sense behind it, because you know what the graph of x cubed looks like, you know what the graph of x squared looks like. If you just accept I mean, I told you why, but if you just accept the fact that near zero you get from this, it acts like just a horizontally shifted x squared function. Shifted x 6 units to the left, that'll give you 0 here, okay? This will act like a horizontally shifted x cubed function. And then I had you graph higher powers, okay? Didn't always do great with those graphs, but they had the right shape. And I'll get a little more specific about them. It really didn't show why they flattened the way they do, okay? Yeah, for higher powers, but I'm not going to be too picky about that right now, okay? We'll incorporate that after we get all this down during the month of November and first week and a half of December, okay? So, here we have those, and I'll talk about the others on Tuesday, okay? But strongly advise you review these notes because the question's going to look a whole lot like these. There are not going to be 22 of them, probably 10 questions on the test, okay? And probably 3 from the first test and 7 from this one or something like that.